All right, so I'm taking a look at exponential growth and decay quiz number 3. This is my first problem, and I haven't gone and looked at Khan's videos to find out how I'm supposed to be answering this. I'm just going to use common sense, so I hope you agree with me. This problem says that a forest has 800 pine trees, but a disease is introduced that kills 1/4 of the pine trees in the forest every year. Which graph shows the number Y of pine trees remaining in the forest X years after the disease is introduced? And sorry, I'm trying to find a blank page in my notebook in case I need to actually do some calculating. All right, so I'm just going to think of this in sort of a common sense way. If you think about it, if it's killing 1/4 of the pine trees, but we're trying to find out how many pine trees are remaining after X number of years, we really want to know how many are left, not how many died. So we know that 3/4 of the trees are going to be left from however many trees there were the previous year, starting at year zero when we had 800 pine trees. So I can tell right off the bat that at year zero, we're going to have 800. So this graph isn't going to do it because it's showing us that we have 900 trees. This graph could, because it's starting on year zero at 800. So B is a possibility. C again cannot be the graph because at year zero, we have, I don't know, over 900 trees possibly. So C is not an option, but D does have us at year zero having 800 trees. So it looks like B and D are possibilities. So also I would probably, without even doing any math, be inclined not to choose D, just because at some point, like after year 5 or so, it looks like this line starts to maybe even go under the y-axis, sort of implying that if you took a quarter of the trees away every year, you at some point would hit zero and go below zero. But if you think about it, you're always going to have 3/4 left, which means even though the population is going to grow smaller by 1/4, or only 3/4 are going to be left each year, you still are always going to have 3/4 left, which means you can never hit zero. You can get closer and closer and closer to zero, but you can never hit zero. And this graph has us hitting zero. So I would say the graph is B for sure. And I would probably quit. I'd say, yep, that's what it is. But there's another thing you can do to make sure it's graph B, and that is to look at a geometric series. And I'm just going to do sort of a rudimentary geometric series. We know a geometric series, or any kind of series, we're talking about terms. So we're going to say we have at the first term, or year zero, we have 800 trees. So the first term, we're going to have, this is term number, and this is, what is this? This is my A, no, that's the term number. Anyway, term number and then the value for each term. So term 0, we have 800. Term 1, we're going to multiply that 800 by 3/4 because that's how much is going to be left. 3/4 of 800 is 600, and we're going to multiply that by 3/4 to find out how many trees are left the second year. And I think we have 450. Let me just double check. 600 times 0.75 equals, yep, 450. And so then the third year, we're going to multiply that by 450 by 3/4. And we get 337. And then year 4 times 0.75 equals 253. And I'm going to actually, I think I'm going to go, whoops, I just lost my graph. I hope they give me the same question. Okay, they did. Maybe I didn't actually lose it. up here, the graph goes up to, it looks like it really goes up to 8 years. Do I really want to go that far? I'm running out of paper here on my pad. I'll do one more. I'll go to year 5. This is just helping me look at my coordinates, because like this is a coordinate 0, 800. Here's another coordinate 1, 600. So I'm going to take a look at these coordinates I'm coming up with and see if they match the graph. So year 5, I've got 253.125 times 3 quarters times 0.75. I've got 189.84, blah, blah, blah. 189 point stuff. Hopefully you can see that. Hold it up. That's what I've got for coordinates. I'm going to decline Mrs. Cox. I'll call her right back because we're almost done. So if we look at these coordinates and compare them to this B graph, we have 0, 800 for sure, and then we have 1, which is halfway between 0 and 2. And look, right at 600. At 2, we should come to 450, and I would say that looks like about 450. At 3, we should get to 337.5, which will be just a little bit over 300. So there, that would be about 300, and we're a little bit over it. At 4, we should have 253.125. So 300 would be about halfway right here. So I'd say this is, yeah, probably about 253.125. At 5, we should have something pretty close, maybe a little less than 200. And yeah, 5 was 189. So I would say this is the right graph. Check. Do I get to check this? Oh, and yes, I do get to check it. Okay, I'm going to stop and do another problem for you.